Suitability analyses are widely used in GIS to classify land or the ocean according to its utility for certain uses, such as conservation, agriculture and aquaculture, or even energy installations like solar and wind farms. Suitability models are considered a type of cartographic model that typically combines spatial layers via overlays, reclassification, and other spatial operations. For instance, if we wanted to identify areas that were suitable for a new solar installation, we might need to combine spatial layers on the topography or steepness of the land, the amount of sunlight different areas receive on average during the year, and whether the areas are close to or far from the existing power grid. For conservation, these types of spatial analyses are common for assessing the suitability of the land for hosting a particular species, and often involve layers to capture whether the climate is suitable, whether there are food and water sources nearby, and whether any existing development, like cities or neighborhoods, might negatively influence an organism's ability to occupy an area. The first step in any site suitability analysis is to carefully consider the complete set of criteria needed to perform the analysis. Can you think of any other criteria that you might want to include when assessing the suitability of land or the ocean for conservation? Once you have the full set of data layers identified, site suitability analysis involves first ranking the values within each data layer to put them on a common scale. For example, if you worked at a land trust and were considering purchasing a piece of land for a new nature preserve, you might need to consider the proximity of that land to nearby cities or development. But you also might need to consider the cost of the land. Since we can't directly compare dollars to miles, ranking each layer on the same scale allows us to eventually combine them. This ranking could be from 0 to 100 or 1 to 5. It doesn't matter too much as long as the values for all the layers are reclassified to the same scale. Once the layers are all on the same scale, the next step is to combine the multiple layers through an overlay analysis. Weighted overlay is a technique commonly used to solve problems like this that have multiple criteria. The layers need to be weighted according to their relative importance to each other. In our land trust example, we might need to give more weight to the cost of the land if we have a limited budget. In other words, we may be willing to trade off for a parcel that is further from the city in order to purchase a spot that we can actually afford. After the weightings have been chosen, it is basic map algebra to multiply each layer by its weight and add up the values for each pixel. The final output is typically a raster surface that shows areas that are highly suitable for the intended use and areas that are less suitable. Choosing the ranking and weighting schemes for a site suitability analysis is often the most difficult part. There are lots of different ways to do this, including asking experts for their opinions or searching the existing literature for guidance. Rankings based on personal values can be particularly difficult to assign. For instance, knowing how to quantify whether an area has good views can be very difficult. In these cases, it is best to work closely with the decision makers to ensure the rankings reflect their personal values. To review, site suitability analyses are a great way to evaluate different locations for different types of uses. Thoughtfully considering all of the potential factors from the start can help ensure that no perspectives or considerations are omitted. Lastly, it is always important to remember that the accuracy or the usefulness of the resulting map for decision making will depend on the quality of the data that went in and whether or not all of the potentially influencing factors were included.